All right, yo, what's up, everyone? Welcome to week 90 of building my own operating system. Thanks for tuning in. Let me just adjust my camera a little bit. Is that better? Let me see. Wait a sec. Get me in a bit more in the frame, I guess. So, all right, today we are continuing working on the physical memory allocator. And I'm pretty excited about that. I think we should be able to write a pretty decent amount of code today. I have a pretty relatively strong understanding of what I want to do, and feeling pretty good. So let's see, a tweet went out, just checking that part. But yes, so last week, we were working on the initial physical memory allocator, and we started working on that after we tried out the memory map feature of Limine bootloader, which I am using. Okay, just give it a quick test 0 in the chat as usual. Nice. So yeah, let's bring up the board, a couple topics for today. So we are on week 90 streaming, and today is the 19th of October. So what's on deck for today? What's up, Creeper? Thank you for the test 0. All right, I want to explore unit tests for the bitmap allocator. In general, unit tests are a piece of just core project infrastructure that I do not have yet, and I would be interested in exploring what it's like to have unit tests for at least some parts of the kernel. And in other news, sorry, I'm just kind of setting things up on the other screen. So otherwise, another topic is the dynamic bitmap topic. So currently we use a static fixed size bitmap for the bitmap allocator. This sets a hard compile time limit on the max amount of phys memory we can support. Maybe it would be nice to make this dynamic. What would that look like? That's something else interested in checking out. So yeah, I think it's mostly what's on the table for today. Anything else from last time? I don't think so. Just gonna get my break timer set up. Okay. So let's just check out the state of Git, what is going on. So some unrelated stuff. Okay, I need to source that self. Cool. So a bit of cleanups, nothing too interesting. Okay, use 64-bit for the phys adder. Adding this little memory map span type. Yeah, so that was just a bit. And then the main commit from last time was, so this is sort of like, this is kind of prototype code, but we were just playing around with processing the memory map, locating the last usable region in the memory map, and then initializing a bitmap allocator, and then printing some allocations out. And in order to do that, I needed to add the memory map request to the limine requests. And then we have the bitmap allocator that we were working on. Okay. Just checking the OBS to make sure the sound and everything is good, but I think we should be all right. I'll update the top text, right? We are working on alloc. Something like this. Okay. So let me see. So let's just sign up. Let's just get back to where we were. Okay. Things are failing. So back to the K main. I'm just gonna add this back so we can return back to what we were doing. All right, thanks, Creeper. What's up, Windows 1.0? Nice to see you. Okay, so that's what we were expecting. This is where this is the state we left off last time. What's up, Battle King? How to start an OS development. I'll link you to my resources page. In general, there's a bunch of classes online, like free classes from universities. And that's personally what I use, and that has been working pretty well for me. Other people will just tell you to look at the limine templates. I think that's NSG's advice. So the limine bootloader templates. Yo, what's up, Bacon? Good morning. Nice to see you again. I hope you're having a nice morning wherever you are. Okay, so bitmap allocator. So last time we kind of prototyped this kind of bad, or it's not that bad, but it's not amazing. One second. Kind of prototyped this sort of rough bitmap allocator, and it sort of does the job, but one thing I want to explore right off the bat is what would it look like to add some unit tests to this whole setup? Yeah, welcome to the channel. Yeah, thanks for being here. No, I'm not that familiar with Valgrind. I've used it in the past, but it's been a long time, so I wouldn't say I really know that much about it. I know it can help you find some bugs though, so. Okay, so what is up with unit tests? So what I want to do is I would like to be able to write some unit tests for this bitmap allocator type and compile that into a binary that runs on my developer system, not on the target system. And then I want to be able to run the tests and just kind of confirm that I have not broken the kernel. I mean, just to sketch it out, there's a couple different ways we could think about doing testing, and that's just one of them. So, so the first way, like I kind of just said, we want to be able to build a test binary that runs on my dev system. So there cannot be any dependencies on hardware or stuff like this. Possible. So we need to kind of think about that when we are designing our abstractions and how we design our dependencies. Another way to do this is actually that test binary doesn't necessarily need to be a binary on my host system. It could potentially also just be another custom OS image that just runs tests and it doesn't actually run the OS. Custom test OS image. In the same way that we're building our production OS image, we could possibly also build a different OS image that just simply runs tests. Maybe there are some advantages to that, maybe not. So yeah, but mostly I'm kind of thinking, this is the more traditional approach, just building normal test binaries. So that's mostly what I would be interested in for the moment. And I might just begin straight up with that. And I think I would need to see, maybe I want to make a branch just for that. Not really sure at the moment. Doesn't exactly matter. So I'm just going to go ahead and get started. So what I want to do is I already have in mind the testing library that I want to use. It is called catch2. And apparently this thing is pretty good. So I'm just going to make a catch2 directory. Then I'm going to make I'm going to git clone it, but maybe I will clone a specific release actually. Yo, what's up, Mario? Cheers, man. Thank you. Godspeed to you as well. I think we're going to go with the 3.11.0 release. It sounds like as good of a release as any. I guess now the question is, wait, so how do I actually, can I just git clone this link? No. I think I need to, I think that's not how you do this. I think you need to, okay, this is sort of a wild guess, but I believe you can pass tag names to the branch command line argument. And I'm going to clone. Okay, I think that kind of worked. So we're here in the catch2 directory. So just going to make the commit thing, and then we have a lot of stuff we don't necessarily need. I might end up actually deleting a lot of this, but not quite yet. I'll just copy in some random CMake lists file here. Third party CMake lists.txt, and we will just catch2. And then obviously catch2, I don't exactly know what it will look like so far, but yeah, so basically just trying to vendor in this library, which just means like copy and paste the library into my project. where it can participate in my build and stuff like this. The cool thing about Catch 2 is it is already aware of CMake. And maybe that will make it easier to use in the build. So there's going to be a couple. I'm going to shove this to the side for the moment. There's a couple challenges I need to solve in the meantime, and so just in terms of this, we're vendoring Catch 2 into the code base. Another thing I need to figure out is how to build binaries for the dev system. This is not completely trivial because so far the build system uses the cross compiler. And it would be kind of new. Yeah, so currently build system only builds binaries for the target platform. Cross compile. And so that's sort of a separate thing. I have an idea of how I want to do this because I did this before in the previous OS I was working on, the JOS OS, that did a little bit of this. Yeah. And then I just want to make an example C++ class C++ file to write tests against, something like this. So just kind of looking around. What else did I? This is just the commit and CMake lists. Okay. I mean, I think there's a certain order of operations here. I think really, actually, this first one is the most fundamental part. I just simply don't have this yet, so that would be good to get going. And so what I'm going to do is I'm just going to back it up. I'm going to go back here. I'm going to make a folder called kernel lib, perhaps. And so this is where I'm gonna just prototype the idea of having a test binary for my host to a dev system. And let's just check it. Okay, cool. So I'm just going to touch a file. I'm going to call it, well, really we need a CMake file. So I'm going to touch CMake lists.txt. I'm going to touch test.cpp. And let's just begin with there. So I'm going to go to my root CMake list. I'm going to add subdirectory for kernel lib. And then here that's the question, what goes here? And I'm going to now pop open the old JOS code base. So let's get that open. Or wait, JOS 2. Okay. And actually I'll move this into JAWS2. Okay, I'm gonna get back into a separate. So JAWS2, I wanna find, let me just see. So this is the old JAWS code base. And does it build? It sort of doesn't, so I don't really know. I'm gonna go back to main and try to build, and that builds. There's a specific part of JAWS that I'm looking for, and that's the FS format part. So here is, okay, not, oh wait, but maybe this was, maybe I already started to delete a lot of stuff at this point, so let me hop back. I need to go to a relatively old part. Okay, yeah, I need to go back before here. So here's where I just deleted so much stuff from the code base of the old JAWS code base. I need to go back a bit earlier in time. And now let's redo things. So hopefully it does still build, and it built a file system image, and that's the part that's really relevant right now. And so I think this is where, what's up, Wall Markets? Nice to see you. You read any books on OS design and architecture before starting? So kind of. I mean, I've been doing this for about 2 years now, and for the first year of doing this OS stuff, I was following this MIT coursework, and so I got a bit of experience. I didn't really read books per se, but I just took that class. I've kind of done a bit of cursory reading on other books and resources, but nothing incredibly structured. Yeah. Why is everyone quiet in the chat? You guys following along with it? Appreciate you, Battle King. I mean, that's sort of how it usually is. Some days are a bit more active in the chat, but not all the time, and that's totally fine with me. UI or CLI only? For now, it's going to be CLI only. Maybe in the future UI, but UI is probably the part I'm less interested in. So I don't consider it a huge priority. So what I'm looking at now is the part of the build system in the old JAWS code base related to the file system. And one of the parts of the file system work was there was actually this tool called FS format. And this is a binary that's built as part of the build system, but it's meant to run on the developer machine as part of the build, and it generates a file system image for the OS, and it links against certain headers in the OS actually. And what's relevant here is that this is building, it says somehow in some way building a binary that runs on the host machine. Okay, time for the 20-second break. Feel free to join me for a quick stand up and stretch. Okay, so there are definitely some open questions that I have about how to make this work, but I'm just gonna have to give it a shot. What's up, Ismail? Good to see you. So I'm just going to, yeah, unfortunately, and this is a major downside of CMake, it does not seem to have good support for running multiple tool chains within the same build. And apparently there are some hacks, and I apparently have been using this in the past, but it is, I don't know, it's unsupported or something, so that's definitely not a good sign. And literally, I'm just gonna make a, like, 42. I'm just gonna make a test C++ file that basically does not do anything. And I'm just going to try to build it. But actually, you know, the interesting thing here is, okay, the way this was working in the past was I was like resetting some of these core CMake variables in the build. And so I think this was over here. So here's the main, this is back, so like, yeah, I'm just gonna screenshot it. In general, here is where I was specifying the tool chain that I'm using with Clang and some other things. And then there's also this native CC, which basically just tries to find a thing called CC or normal Clang on my system. And so what I was doing is I was basically resetting this C compiler variable to point to the native CC and resetting the linker. And apparently there's like this template of a compile command kind of thing. So I'm gonna just call this test bin, for example. And in here, I want to do, maybe let's just try the same approach. So I'm just going to copy a couple of these lines also over. I'll just call it native CC. So and I think I'll need to unset the CXX compiler target also. So I don't know, let's just try this. Not really sure how this is going to work. But what I'm going to need to do is I'm going to reconfigure the build. And then now I'm going to try to build test bin. And I got a warning, but it actually did seem to compile. Interesting. I'm going to take a picture of that. And theoretically, I can now run kernel lib test bin status, and it worked. It returned 42, and so that is actually seems to be totally working. If I'm a little bit braver, maybe I can try to do some more stuff. What am I doing? Echo stud cout hello from test bin. So that I'm going to again build. Okay, so now here's where we get into problems. Okay, now as soon as we start to use any headers, things break, and that's kind of a problem. No such sys root. So I might have to whip out an AI tool to help me speed up the process here. So I'm going to make clean, and then I'm going to do a verbose make test. This should fail, right? Test bin needs to be spelled like this. And okay. So yeah, in general, I mean, they can be kind of satisfying, but in general, I want to spend as little time as possible working on the build system as possible. Okay, so here's the command line. Oh, check this out. This is interesting. Opt homebrew, blah, 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 blah. And that is why it is actually using the cross compiler to try to build my host tool, basically. And that is not really expected to work because the cross compiler well, it does have a standard library embedded into it, but then it runs into other problems. And I should not don't have this defined, right? Do I? I actually do. Yes, you are in the right place. That's what we do here. It's literally exactly what we do here. Working on this OS. Okay. Okay, wait, so this, oh wait, that's why it's I need CMake CXX compiler also. That's right. So actually native CC is actually already defined earlier in the tool chain, and I was missing this line, and therefore it just continued to use. It saw that I was compiling a C++ file, and it went to CMake CXX compiler, which was still pointing at the old tool chain. So let's run it one more time. And I think this is, wow, this is ugly, but I think that's a bit of progress. Give me 1 second, I'm gonna grab a hoodie over there. Okay, so, yeah, I like this discussion about projects that people are working on. Feel free to post about what you're working on these days. I'm also kind of looking at you, Bacon. Curious what you're working on these days. Undefined. Okay, so we've graduated from a compiler error to a linker error. And check it out. So here is, yes. Yeah, man, well, I gotta say, that is kind of the vibe around here, Battle King. So definitely welcome to hang out. Okay. So here it is. Oh, flare on. Oh, nice. Very cool. I've never done flare on, but I've heard a lot about it. That's pretty cool that you're working on that. So you can see here, it is finding the user bin CC. And so that means it is properly using the host compiler now. But now we run into this really incomprehensible error, and this is the part where we pop open the AI. And I've been using Claude lately. So help me, please help with this compiler error. CDB and make, oh shit, my phone just answered me. What? Okay, CDB and make test bin. Let me just so now it starts to read the meantime, I'm kind of curious. What happens if I just go with Clang? Ah, wait a sec. Oh wait, no, I know. There we go. Yeah, the problem is I was using a C compiler instead of the C++ compiler, and that will do it. Native CXX, CMake linker. Now that is interesting. I don't completely know, but I'm just gonna go with normal Clang. Let's try this one more time. So now it seems we've regressed back. Wait a sec, what happened here? We've regressed back to the original error. I think I think I need to regenerate the build actually. No, wait, what? What's going on? Why is it using this again? What? What? Wait, let me. What the hell happened just now? Okay, so let me get back to where I was. So I was using CC, right? Okay, good. So now, right now, so now we have the error. Native CXX. Oh, wait, this is actually maybe interesting. Okay, first off, I need to know how to debug print a variable in CMake. I need to go with the message. So I'm gonna go with message. CC. All right, 222. And can I see what this prints out? So check this out. This is interesting. So I think I need to nuke. I need to nuke something. Let me try to, yeah, okay, now that changed, but it's changed in the wrong way. Changed in the wrong way. So now it is finding a clang, but it's still finding the tool chain, no, the tool chain, the cross compiler tool chain clang. What's up, vpool? And I need to not do that. I need to. Is user bin clang plus plus? I want to use user bin. So I wonder, can I mean, really what I could just do is hard code it. I could literally native CC clang. Like just to get this working, let me okay, so now I'm just really forcing it to use the user bin clang, which is really my system host compiler, and I'm just really trying to bypass whatever is making it find my cross compiler first. And this is sort of a barbaric way of doing that, but now that I have this, I should be able to try this. And so now we run back into the original problem where now it's not using the C++ compiler. So now I'll just do this. And then let's run that one more time. And it didn't work, but I'm gonna nuke things again. And let's just run that one. Oh man, what? So now it's probably because of the CMake linker. I don't know. I think that's probably the reason. CMake linker needs to be the C++. And check it out. That worked. And so now I should be able to run. There we go. Finally. Okay. Hello from test bin. So that does seem to be working. So now I am fairly able to yeah, to build host tools and stuff, and I can apparently I can link against system libraries and stuff like this. So I'm going to call that an initial win, and so that's this part. So this part is done, and just in time for another quick break. So I'll be right back. Word, okay. So Now, again, the idea is getting unit tests running, because we wrote this bitmap allocator class last time, but that was just in the kernel's source code. And it could be cool to have some way of like running an automated test suite that can check if the code is right. So I don't need to like run the kernel and test it every time. That's like the whole idea behind automated tests. And I want to see if I can do that. Yes, sir. And I think we're like on our way. So now that we have this fundamental ability to, maybe I'll just move this down. Makes it a little bit prettier. Or not, I don't know. Maybe we'll just keep it nice and tight and close together. So now that we have this fundamental ability to build binaries for my host system, I mean, the really cool part though is that it's all within the same build. Wow, what is this? Those are, I feel like these are new warnings, but whatever. Okay. So the cool part is this is all within the same build. And technically this is using that unsupported behavior of CMake that is like kind of sketchy or whatever. But it's really nice that I could just have this one build and I can trigger builds of like the kernel elf and it builds that, or I can trigger a build of my host tool and it just triggers that. And it's all within the same build. That's pretty nice. The only not nice part is like the fact that it's a hack or whatever, but the hack seems to be kind of working. So we're just gonna go with that. Okay, next up, I'm just going to stage some of these files. Third party. I'm going to do whip build host binary. Yeah, adding a bunch of whip commits, and we will clean up the history a little bit later. So now we're in the world of trying to integrate this catch2 library. We already have our third-party library with that, which has a bunch of other third-party libs, and so that's where it's going to go. And now I just need to figure out how to do the smallest amount of integration work to get catch2 into the build. And here's the part where I sort of don't know, but I think there is documentation on this. If I search for CMake, do I mean, catch2 docs, temp docs command line. CMake how to. I think it's C source tests. It's the old find package, but I have it in my, what's the, just out of curiosity, I think, okay, I'm just gonna ask AI. So I want to integrate catch2 catch2 into my, what's up, Tugra? Oh, I missed some chat messages. What's up, Tugra? And yes, I use catch2 quite a bit at work actually, and so that's sort of why I'm using it here. And this command line UI, what we're looking at is I have tmux, and I have lazy git for my git client, and fish shell for my shell. To my build, I believe it natively uses CMake and can be easily integrated into a CMake host project, which I have. I want to be able to link against catch to build targets that are exported by the catch2 library. Is it as easy as add sub directory? I am vendoring in the catch2 library. Okay, let's see what the old AI says. In the most trivial case, I literally just do an add subdirectory. Yes, and so that's, and that is the kind of cool part about using CMake. Even though there are some downsides, if there are libraries out in the world that also natively support CMake, in theory, it's very easy to interoperate with them and bring them into the build. So, Shayamendra, it is not publicly available at the moment. Yes, but pretty much everything has been on my screen at one point or another. So I do not have a public Git repo though yet. Okay, we need to find the catch2.cmake lists. And if this is as easy as say it is, I just need to add subdirectory upstream. Yes. Will we be able to test the OS? Not at the moment. Maybe someday, but for right now, it's just kind of my personal thing, and I'm very much encourage everyone else to build their own OSs. Yeah. Okay, so let's just try add subdirectory and then link against catch2. So this is sort of what it's going to look like. I'm going to, yeah, let's just try making a basic test, catch2 with main. And so now we're going to go back to the kernel lib CMake and target link libraries, test bin private. Right. And then we need to maybe change this a little bit. So let's just add test case, my test. And we're going to need to target link libraries. And include, now there's the question, what do I include? Include, I don't know, this include? Okay, do not know. I'm just gonna give this a try, so, oh, which is not, okay, I need to rename this catch to upstream. Damn. What? Damn. Okay. What the hell? Move upstream. Okay, one more time. So, oh, okay, so now, okay, here's possibly the annoying part. All right, what do you think about performance between C and C++? Yeah, maybe because C++ abstract stuff and predicting in some ways not straightforward. I do completely agree with that point. I mean, sort of the point of C++ is to have more abstractions. And sort of by definition, that distances you from the final assembly. Overall, I think that what you get from C++ is well worth any performance difference there might be. And the whole point of C++, like one of the key principles of C++ is that there should not really be a performance difference from raw C. I do think in practice there can be, because C++ makes it easier to do things that have a performance difference. For example, in C++, it's much easier to work with dynamically allocated strings, whereas in C, you just might not do that. You might just use static strings or something like this. And so it's not really a good comparison, because while technically C++ might be slower because we're using dynamic strings, you also get something from those. You get nice features from a dynamic string, which you don't get from doing it in the C way, where you just don't do that. So overall, I'm not at all worried about any performance difference, and I think the benefits you get very much are worth it. Maybe I'll slightly rephrase that. I think the benefits you get are worth it. There are many downsides of using C++, but those are not significant enough for me to not use it. Yeah. How do you research what component you need? I sort of don't know. I'm sort of going it very step by step. I'm mostly following the same general path I followed previously with working on the JOS OS in terms of the components that it gradually introduced. What's up, Sensei? Yep. VS Code setup is not really that interesting or sophisticated. I just use the Vim plugin. Okay, so basically what happened here? I tried to build things and now we ran into this error, and the error seems to be coming from actually trying to process the catch2 library. And you can even see it. Target compile features, no known features. Okay, I'm gonna need to bring, please help debug the new compile error, cdb, and make test bin. Now this is the part where I really no known features. CXX compiler. Interesting. Oh, what? Okay, that's bad. Damn, okay, it's using the toolchain, it's using the cross-compiling toolchain. Okay, interesting. I think, yeah, this might get messy. I think I might need to several things that are not normal about this situation. Let me catch two. So I think I might need to like inject this. I don't even know if that will help actually, but I do not want catch2 to be using the cross compile tool chain. So oh wait, damn, I just did not want it to actually do that. Fuck. Okay, I don't know what, so I don't know what it just did there. It added these things. Wait, interesting. Okay, I'm going to comment that out. All right, do I not run Claude with that dangerously skip permissions? Apparently not. I just ran the normal command. Okay. So I have this thing here. It did not make a difference, I think. Clang uppercase, yeah, that's super weird. So perhaps it's time to try this suggestion. The thing is, I actually set it to use C++23 actually, but I think I did this in kind of a weird way where I'm manually adding this flag here, and maybe you're not supposed to do that. So you know, let's just go with 23, and I'm going to copy this also into here. Damn. Wait, what? Okay, my prediction is that this is not going to change anything, but I would love to be surprised. Fuck. Okay. Maybe I'll give it some more context. The text in the CMake error suggests that the catch2 library is seeing the cross compiler, but I do not want that in kernel lib. I want it to use the host compiler to build a host tool. And the goal was and I only want catch2 to be aware of the host compiler user. So there's a possibility that this doesn't work out, which is okay. The fallback solution is maybe I can have a separate build, which I was really trying to avoid that. Okay. Oh, the problem is that add subdirectory third party is being processed with the cross compiler settings. Either move to kernel lib only. Interesting. Remove catch2 from the main and add it directly. Okay, now this is an interesting suggestion. Okay. That caching needs to be processed after you've reset the compiler, but not before in the main build. Okay. All right, this is, okay. This is getting very messy, but let's just do it. Third party, wait. Third party catch2, no. Third party CMake. So we're going to not do this. Wait, we're going to, yeah. The files are still going to live in the third party directory, but I'm not, as far as CMake is concerned, I'm not going to add directory here. I am going to do this like really crazy thing that it has suggested, and just try. Truly not really sure how this is going to work. Also, quick look at the dev docs. What add subdirectory. So we got a source dir, a binary dir, and system. Looks like we're passing a binary dir of catch2. The binary dir. Okay, I don't know. Interesting. So, but wait a second, this needs to potentially come after we've reset the variables. I sense Claude is cooking a Michelin dish. Yes. Okay. So this stuff is suspect. I'm gonna remove that. Okay, this is interesting. So, I mean, but the thing is, I already sort of did this in my catch2 CMake. I was pretty much trying to do the same thing. I was trying to set all these variables before going into this subdirectory. That did not seem to work. So, but whatever, maybe I don't know, maybe I'll still try it. All right, let's just try this one more time. I think it's the same problem. What happens if I just don't do this? Wait, okay, so now, okay, good. So it actually is interpreting this. Target compile features, no known feature. Oh, wow. All right, be right back in 20 seconds. Does that line need to be at the top? If you're talking about this add subdirectory thing, I think I want to say that it's important that it is actually after this big blob of settings that reset a lot of these compiler variables. No? But the thing is, yeah, it is for some reason. And this is probably why this is where we run into the fact that what I'm doing is unsupported by CMake. What is going on? Stream source CMake. I want to see let's just take a look at. So now we're in the catch2 source code. And here's the part where it requires a particular C++ standard. Maybe I'll just put this into the AI also. Does this. How what's my question? What can I set in my host build such that this passes? I am definitely using at least C++ 14, actually more like 23. What's up, digitalized? I'm attempting to get unit tests working for the kernel. And I'm trying to integrate this library called catch2, which is a unit testing library. And it's not easy. It was going okay, and then now I sort of have hit a little bit of a wall of trying to actually build a test binary, a unit test binary that runs on my host system. Okay, now it's saying the way you okay, I'm just gonna try this. I mean, we kind of already tried this, but I will try it one more time. We're going to set these variables, and we're doing that right before this add subdirectory call. And I kind of expect this to fail. I'm going to be absolutely no progress. It always is finding the cross compiler, which is kind of funny because the cross, what if, wait, you know, toolchain, technically I could set these, let's put it as 23 here. Let's put it also as 23 here. It seems like, okay, let's break it down. The catch2 code base has some code that verifies that the build system, like the project, is at least C++ 14. It does this by using this compile features thing. In this case, it had no known compile features, which you'll love the method. Yeah, let's just try this. Wait, let me just try this. Damn, still not. What the hell? What do you mean, no known compiler? So what if I do something like invalid, like 2,333? Okay, no, I'm getting a little bit suspicious about this. Time to go. But it is true that ChatGPT, and to YOLO the method missing, right? There was this other option. If who knows what this policy thing means, but I will do anything at this point. Policy, blah, blah, blah. I'm gonna add this in 2 places just to make sure. Something still is wrong. Okay, this All right, thanks for checking, Ismail. I think my setup is just like weird. Or I mean, it's not even that weird. Okay, this Stack Overflow is super weird. This is more like what the hell? Deleting. Interesting. So this is somewhat similar. Nuke everything. I don't even know. No, there's no way that makes a difference. Is there? How to generate the CMake build from the root dir and pass the b dir. I forgot how to do that. Yeah, okay, dash, right. CMake dash b. Oh wait, what? Oops. There we go. Okay, no difference. So that, yeah, not too surprising. It's got to build from inside this directory instead of with your flags. I'm not sure if I understand, to be honest, the question. So this is weird, but downgrade. Okay, this seems odd. So cd catch 2 and CMake. No, okay, I see. I think I see what you mean. No, the way it should work is, Well, yeah. If I did that, like cd and then CMake, it would, I don't know, it would be creating a separate build directory. And I'm pretty confident that's not how it works. Dang. Okay, well, this is proving to be extremely difficult. Maybe not extremely, but it still does not work right. It still completely is not working. And basically no known features. Target compile features. I think it's a good idea, but I think it's unlikely that their upstream is broken. That would be very surprising. Target compile features. I wonder if it's just something completely different. Maybe time to learn about what does this target compile features thing do? CXX compile features. Specifies required when compiling a target. If the feature is not listed in blah, 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 then an error will be reported. Oh, interesting. So this kind of sounds like I need to set something here. If the feature is not listed, so I need to CXX compile features. Kind of curious what, maybe it would be interesting to dump this. Let's try that. What? Okay, I think that worked. So as suspected, this thing is empty, which would make sense. So back to the dev doc. What is this thing? So for some, okay, so this is a bit more information to pass to the AI at least. Seems like my is empty. Is this normal? How do I get it to be populated with all the features, e.g. from C++ 17? I feel like, yeah, interesting. Empties, right, just to confirm, did I do this right? Message CMake CXX compile features, right? I'm trying to dump the CMake CXX compile features. We tried to do this, clean it out. That thing does not have anything in it. And it's saying, enable language. Did I do this? Okay, I think that this feels a little bit like a lead to me. instead of, you can patch catch 2 to use this thing. Okay, that is maybe a last resort. Force CMake to test the compiler? Okay, this is interesting. So this thing, enable language, this thing seems to kind of work. And now it's saying the compiler is unable to even compile a program, which is kind of expected because this is our cross compiler. Okay, so that's, it's kind of working. So I'm curious. So this is in the toolchain.cmake, which is for the entire project. I'm going to go into here, which is our, which is where we are kind of messing around trying to make this catch 2 thing work. I want to just gonna try one more time. Okay. Still empty. Yeah, so even though we are overwriting some variables here, that seems to work okay for the purposes of compiling a binary, but for the purposes of adding a subdirectory, it does not seem to, it is not respected, basically. It does not seem to be respected. And it seems to just go straight back to the original compiler that was defined the whole time. I still feel like, we're getting somewhere though. So it's all about this list, right? This compile features list. Maybe we read this quickly. So the idea around this, I think it's kind of right here. The way they do it's about the granular handling of what features you need rather than specifying a language standard. Wow, already another break time. All right, 20 seconds. Be right back. I don't know if it's, I don't think it's a 23 thing. I think it's some kind of strange cross compiler thing. So you can express that a library needs some certain features. And here's the part that we're getting into. Projects that use a large number of features may specify a meta feature. Okay. So it is doing exactly this. It's specifying C++14. How does, man, why is this get populated normally? Project enable language. Enable language is interesting. Enable language. Apparently I never did this. This is the same as the project. Wait, in my project command, wait, I know I am specifying some languages here. So okay, this does not really say anything interesting. It must be called in the highest directory common to all targets using the named language. You're changing this after the project call. Ugh. Force. After, okay, reset. I'm going to try this. Force to redetect compiler and its features. CMake. No, but it's not. What? It's not even doing this, right? Or is it? I mean, apparently it is doing this because we print the 999 thing, which is all the way over here, but this thing is still empty. Okay, we're approaching serious last resort settings. This will make instead of cross compiler. Look at the first mark crash out live. It's possible. Anything is possible at this point. All right, we might have to go to this with this thing, which is the craziest possible solution for this. I don't even know. I don't even know what this is. Set CMake. We're just going to straight up set the string. And if that's not a hack, I do not know what. Oh my god. That worked. But oh man, wow. Okay, so now what? Do we just try to build the program? Holy crap, it's working. Wow, look at how slow that is. Dang, why is that so slow? I mean, I'm not using a parallel build, but man, okay, cache 2 is kind of heavy, isn't it? I'm just gonna let it do its thing. I'm like almost too scared to even stop it. But indeed that hack, that incredible hack, like it seemed to completely work. So time to run the pro. Check it out. It actually worked. Whew. So this is nuts. This is absolutely nuts. So now it's time to comment stuff out and see what was the minimum set of changes. I mean, it works in massive like air quotes, because now I feel like we're getting into like really deeply unsupported things right here. But I'm just gonna comment out. I'm gonna move this back up to here. And I wonder if really the only thing needed to make this work was the set blah 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 thing. And I'm just going to delete everything, regenerate the build, which worked, and we'll do a make-j this time to make it go a bit faster. Also, maybe it's hitting the C cache. So cool. Okay, so seems like all of that was like not really for anything. And I mean, I wonder, okay, so this part was definitely necessary here. Now I'm wondering about this add subdirectory thing. Can we move this back? I sort of feel like we should be able to move this back. Yeah, that was a fight. It's been a hot minute since I have had something like that happen. Okay, so now we're going back to the catch 2 CMake lists here. And I'm gonna take what we have learned and we're gonna put this here. And I even am gonna go as far as uncommenting this out. So now here's the idea. We have our catch 2 and we're gonna remove this, and we'll go back over here and add this back in. And so now let's clear it all out and try it again. And it doesn't work. That is interesting. Okay, I was just trying to kind of clean things up a little bit. Wait, what? Error? In wait, I'm confused. Okay, for whatever reason. So now if I add this back here, now let's see what happens. That actually did work. So this seems it seems necessary that this is here. If I remove this, CMake, it does not. So I need it in both places. But kind of cool part is that it seems like I don't need this. So if I have this here and there, and then now, oh, whoa, okay, so now it's not compiling actually. So now we need, so wait, so is this necessary actually? So now if I come back over here and just kind of replicate the same things I had over here, now let's try. And now it is actually working. All right, we are deeply, deeply in the world of hacks, but it actually does seem like it's working, which is kind of cool. I am wondering if there's some way I can make maybe like a CMake macro or something that just like puts which I can include in these two different places. And I mean, maybe that's something for another time though. I just want to try to get this working for the straight path. So idea, use a CMake macro for the ultra hack to get catch to not fail the build configuration. Okay, anyway, so now let's actually just check out what like this test looks like. So here's like a test, and I can do things like check x equals 42, for example. You know, this is like a kind of a dumb test, but I should be able to do things like this now. And if it fails the test, it looks like this. So we have it seems like we have a fully working catch 2 setup now. So that's kind of cool. So now, okay, maybe time for another commit while I'm getting things to work. So, okay, here's the interesting bit. Are any of these changes needed? I don't really think we used any of them in the end. Or not, wait, okay, crazy. What? So was this stuff necessary? Okay, so a bunch of random stuff was necessary in a couple places. Anything particular about catch 2 better for OS dev? No, not really. That's not really why I'm choosing it. I'm just choosing it because in general, it's a pretty good unit testing library for C++. Nothing, and really the way I'm going to be using it, it's not really OS dev at all, because I will only be able to unit test classes and code that have no dependencies on hardware or something like this, or and so in that way, it's just sort of like unit testing normal generic libraries that can run in any context, basically. For example, the bitmap allocator we wrote last time is a good example of code that has no dependencies on hardware. It depends on these Lie-mine data structures, and so it takes in this array of these like Lie-mine memory map data structures. But other than that, all it does is have some internal data structure and do some mutations on that and stuff like this. And so there's no dependency on the hardware here. And so it would be entirely possible to separate this out into a library that can be compiled into a normal test binary and run against some test cases. Yeah, so I mean, it's like some assertions and some infrastructure for like you can like have some different sections and stuff like this, and you can kind of structure your tests in a certain way. I don't know. You can, yeah, there's like, it just has a bunch of features that are kind of useful. It is kind of a problem that it's so big. I do not love that it takes kind of a while to compile. I mean, with the parallel build that goes kind of fast on my machine, but it is true that it's sort of a heavy dependency. So that is a bit of a downside, but I'm just gonna keep going with it. Okay, so now this is this is interesting. There's something here that was necessary to make the build work, and I'm gonna guess it's this policy thing. I'm gonna remove this, and the build fails. Wow. So it was something here. What? Is it this? Okay, this is deeply mysterious. It was that line. It's the C++23 line. Wow. I don't really get it, but okay. Okay, that is, yeah, this. What about this? So can I get rid of this? If this thing failed though. Interesting. But I can still build. Wait. Interesting, it says performing blah, 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 but failed. But then it sort of just keeps continuing, and then the build does seem to succeed. Or does it? But it got pretty far. But then the linking takes a very long time for some reason, which is interesting. So, but if I have this thing in there, it still fails the build. Okay, so I guess I'll just remove this. So basically, this seems to be a collection of changes needed. I don't know. Whip minimal changes to get catch to configuring and building. Oh, okay. Kind of, I mean, very, very sketchy, but it's kind of cool that we got this far. And now what I want to see, okay, so that's working. So now kernel lib. Oh yeah, yeah, lazy git. So now we sort of have this initial setup, and I think it would be kind of cool to, let's just bring in the kern frame allocator.hpp into here. Right, test.cpp, and let's include it. Frame allocator.hpp. Wait, oh damn, I got rid of the, okay, I dropped dropped some important change actually. Oops. Test. Wow, what am I doing? My test. Sorry, I accidentally deleted. Okay, let's one step back. So okay, syntax error. I need to include catch to macros. Okay, cool. Okay, that's working. Did I get the dash v? No. And it's failing, right? Good. Okay, great. So now we're in a position where we can start writing a unit test if we want. So now let's add another test for frame allocator. And something like this, but now we're okay, first things first, I'm just going to try to include the header. And let's just see how, if that, okay, interesting. So now it's trying to include lemine.hpp, which is not, so now we're getting into the dependency here. And so lemine.hpp. And really it's just for this type though. This is the thing that really is compiled into the kernel, but frame allocator really only needs this one type, memory map span. So maybe that is a reason to separate this out into a separate header. So what I'll just do is, for the moment, I will just copy lemine kern.lemine.hpp into here. I will rename it lemine helpers or something like that, or lemine util hpp perhaps. And now I'm going to make kernel lib.frame allocator depend on lemine util. And in lemine util, I'm going to get rid of basically all of this. I'm going to get rid of this stuff. I guess I still want revision 3 with the lemine here. And I guess I actually do need a span, so I can get rid of this stuff. Right. So now this thing has been sort of like separated from the core kernel code, and now but memory.hpp is the next thing. And again, that's just for the same thing for this phys_adder t type. Right, we don't need these other things here. And so I will pretty much just do the same thing. I'm going to copy current memory.hpp into here, rename it memory, memory types.hpp. Just kind of freestyling right now. And I can get rid of this. No, I can get rid of this and this. So now we just have a nice simple header with our phys_adder t thing. And now frame allocator in kernel lib can tend to memory types. So now it has been officially decoupled from the core kernel code. And it just depends on these kind of lightweight headers. But it still depends on frig and a bunch of other things. And so that means now in the kernel lib.cmake.texts, we will need to link some dependent. We will need to link frig here at least. But I'm just going to run the compile just to see what happens. So once more. So now we're right. So now we're unable to find lima.hpp, and as another hack, I'm just going to do the exact same thing, but I'm just going to copy kern.lima into kernel lib. I think ideally it would be in its own like build target. In the same way we have like frig in its own build target, we can make a target for the limine header. But for the moment, I'm not going to do that. And so now here, we're getting close, but so my prediction for the next error is that we will not be able to find the frig bitset header. So let's just run it. That's the next error. And then to fix that, we're going to depend on frig. Xfrig is the name of the target in the build system. And I think actually it should compile maybe. Ah, wow, this isn't. Oh, and now this is, oh, this is interesting. What does it say? Tried including, but did not find C++ the def header. Oh, okay, wow. Now this is probably, what was going on here? So, okay, various, it's from the IO stream actually. But now something tried to include this, but it could not find this header, and I'm pretty sure I'm gonna do a clean, what's up hello code. Can I use it on my device? Not yet, very much not yet. The kernel is still super early. Okay, I don't want to take forever with this. I'll speed it up with the -J. Cheers, thanks for the sub. Okay, let's take a look at these flags. GNU 20, for some reason we're getting GNU 23. But you know, this is really interesting actually, because oops. The error I was expecting to see is so, like I expected some kind of command line about like no stood inc or no stood libraries or something like this. But none of that's here actually. But did not find lib c++ stood def.h, dang. Header search path should contain the before any, and you probably are using compile to make that not the case. Okay, something is very wrong about that. I wonder if I can quickly fix it by not including IO stream potentially. Oh, okay, that didn't work because catch. Wait a sec, didn't we have this compiling already though? Like why, like what changed? What changed? We had this, like, we had a test binary completely compiling and working. But as soon as oh man, as soon as I included frig, that's when things got frigged up because what does this mean? Frig interface. Oh, frig, something about this. I think it's something about the C headers. Let's try making another one. I'll call it frig host, maybe. And in the frig host, we are not going to depend on the freestanding C headers, because in this case, we are able to rely on the system headers. So this is like kind of crazy, but let's try it. Frig host. And now one more. Okay, I think that worked. So now I can try to get both of these back actually. And maybe I will just do a clean and I'll remove the verbose flag. This thing kind of slow to compile. Mechanical keyboard for competitive programming. Honestly, I have no idea. I do not do competitive programming. And I also don't have a mechanical keyboard, so I just do not know. But now check it out. Here's the part where we can, now we're pretty much ready to just write our unit test actually. So to do that, we need to be able, we're going to instantiate the bitmap allocator. And to do that, we need the memory map span. And so we need to basically make our own like kind of mock container entry. It's going to be and we're going to need to include array, right? And this is seemingly not compiling, but let's try one more time. Oh wait, yeah, I need let's put in like 1 and have it be null pointer. So we're going to do the most minimal setup here. And this thing requires the span. And we can just construct that with the map dot data and map dot size, I think. And then now we've successfully constructed the bitmap allocator in our test harness. And we can do some things with it. And so in this case, we've passed an empty memory map, basically, or it has one entry with a null pointer in it. And actually, since it's a null pointer, I think that means it's going to assert. That's because, actually, is it? In our code here, we auto p entry in the, yes. So here we're going to null pointer dereference. So I'll add the assert here, just so we can see it. Oh dang! But the assert macro is not available, is it? So I would need to do the exact same thing where It's like assert.hpp. I mean, I can try to do that quickly. Copy kern assert hpp into here, and so assert, and so now okay, now it starts to just drag like everything else in here. So now, and here's the part where it starts to become tricky. So here, so far we've just been dragging stuff. We took this one piece out of the kernel, and we realized the dependencies it had on other things, like the memory map span and the phys adder type. So we had to drag those out. And then now to be able to use assert here, now we need the assert header for this thing, but now we're actually starting to hit the hardware because here's the part where we directly depend on x86.h to do the halt instruction. And so actually it seems like assert would be one of the things that would need to get mocked out or something like that potentially. So again, just for like a hack for the moment, I'm going to comment this out. And unfortunately, logging is also something that is currently directly yeah, logging is also directly dependent on the hardware at this point. Did Terry Davis use any dependencies? Good question. Yeah. Did Terry Davis have unit tests? That's the real question, I think. And I want to say no. I think a lot of hobby OS developers don't really do unit tests. Probably for this reason, because it's like sort of annoying. Because it really makes you aware of what your dependencies are on objects. Unfortunately, assertion is pretty fundamental. So I think some solution for that is going to be needed. How to allow assert in code that is unit tested. That's kind of an interesting question that's coming up. Because the idea is to have the idea is that a bunch of code in the kernel should not necessarily need to like depend on hardware. Like a lot of the kernel's code should just be sort of like these generic data structures that don't have any particular dependency on hardware. They just happen to be in the kernel. And for these kinds of things, it would be nice to instantiate them in test harnesses. But let's just map it out. What could a simple one look like? So let's just try it out. So with C++, a cool thing you can do is just sort of like directly initialize these things. And what should my type be? I'm going to make it reserved memory. My goal is basically, to have, type, right? To just have like a super minimal memory map that basically has no usable memory. And I was trying to like be cool and use this .base blah 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 thing, but maybe I just won't. Let's see what the compiler error says. Field designator cannot initialize a non-class type. Oh, it's a pointer. Wait, oh yeah, wait, it was yeah, this is a pointer. So actually, what do I do? I guess. Okay, so what I need to do is maybe I need to make an actual array of these things. Let me just quickly. Does this work? I have an array of one of the structures. It's actually still not letting me do it. What do you mean a non-class type? Can I do this? That works, I think, right? Okay, so this fancy syntax with like the dot thing, I don't know, that, or tree. What about this? Okay, that actually does work. So, I mean, this is like kind of verbose, but yeah. So basically I created an array with one thing, and now I want to have an array with an equal amount of pointers. Oh shit. Map data, map pointers, and for example, I could just for auto each in map data, I could just go and set map pointers. Oh, but I need the index. Okay, so dang, for int I equals 0, I is less than map data dot size plus plus. And then I just set map pointers I equals the address of map data. And so this is sort of, now we can pass map pointers into this thing. Okay, so that's all just to set up our sort of like our mock data for the type. In reality, it's the Limine bootloader that's crafting these structures and passing off this array type of thing to us. But in our test harness, we just choose our own test setup, and we've designed our interface such that the bitmap allocator type, all it requires is this span of pointers to these structures, and that's exactly what we're giving it. And now what we can do is we can try to just use dot alloc, for example, auto p, for example, and in this case, so here's our very first unit test. In the case that there's no usable memory here, and so there's just no usable memory in our given memory map. We pass it one element of reserved memory, so there's no usable memory. And so when the alloc function tries to go through and search for a free bit, it's not going to find it, and it's going to return null opt. And so this is a real life unit test. We can test that the physical address. I mean, there's different ways we could do it. We could test that it's equal to stud null opt, for example. Another way would be just this. Maybe that's a little bit more concise. And that's like that's like not joking. That's not joking around. That's a real unit test. I'm serious. I'm serious. It's a real unit test, and we can run the test suite now. We can get rid of our fake thing. That's like a real life unit test, and we can see that our test suite passes. And then let's just say that I'm working on the code a little bit later, and I introduce like a bug where I just return the number 2 from alloc at all times. And now I'm curious whether my kernel still works. I'm like, is that a smart change to make? I'll run my test suite, and shit, it still passed. Why did that pass? Wait, what? No way. How did that pass? I must have done something wrong. What? Oh shit, I modified the wrong file. Okay. It's because I copied the frame allocator .hpp into this other directory just like to get that like working quickly, and I mutated the wrong one. Okay, let's say I'm working on my kernel and I return 2 at all times from the allocation function, and I'm curious if that was a smart change. I rebuild my tests and I see that they fail, and I observe that I broke my kernel because we're testing that in the case that there's no usable memory, we want to be returning 0. And frame allocator. So now this is a good opportunity to make a section because there's a bunch of different stuff I could test. And this was no usable memory. Right. And so that is like our first test. And probably it would be nice to have a helper function that that makes it really easy to create these test setups. Oh, hello code. What university are you studying in? I'm not a university student actually. I'm just a guy. Yeah, I think it'll pay off to have this safety net when I add more features. I kind of hope so. Yeah, so there's clearly some kind of use you can get from having this test setup. It also is kind of annoying. Like we needed to deal with a bunch of annoying dependency stuff. If we just didn't have unit tests, we would not really need to think about these like header dependencies and like all this and like the assert problem and all this stuff. But in general, I think it probably is worth it to some degree just to have a bit of infrastructure around for doing this. And yeah, I mean, at the very least, it's kind of just fun to try setting it up, even if we're not going to use it everywhere, even if it's not like an amazing idea. I think, I mean, even this was kind of cool just to have like our first test. So I'm going to kill the palm tree now. And yeah, I think, let's see, anything else to do? But I would call this a pretty successful day though. We started out with like nothing and ended up with a unit test binary that is running on my host system using catch 2 and testing this class which we've extracted from the core kernel. So that's pretty neat. I'm just kind of like idly wondering how to improve this. So what I want to do is I want to have some kind of helper function that's like, or maybe even a class itself. Yeah. Group project, think about testing from the beginning. Yeah. Totally. Testing is something that's good to do as early as possible, because you can imagine if you just didn't think about testing for a long time and built a ton of kernel code and made this huge big project, it might be pretty difficult to extract things out of that at a later point. And yeah, like as an in real life example, I mean, maybe this is not the best example, but I just always think of GCC and Clang when I think about this. So GCC is much older than Clang, and GCC is famously known for like not being reusable as like a library. Like Clang was an LLVM was designed from the start to be a library, and to be a collection of libraries which you can then link into other applications. And GCC never had that. GCC was always this like monolithic blob of a project. And it's kind of a similar thing. What we're doing here is basically making our kernel less of a monolithic blob and more, and now we basically have the kernel, and then now we have like these like separate headers and just kind of like code that's sort of like decoupled from the kernel and can be linked into something else like a unit test. So yeah, this is sort of how I'm approaching my testing strategy. And it was sort of annoying to get the headers and stuff figured out, but yeah. Clang D LSP, what's up, Desi? Yeah, Clang D, super lit. Okay, I'm just sort of imagining what this could look like in a better version. What if we had some kind of helper? This is not memory map helper, and you can construct it with but okay, so it's going to take some kind of container. Oh wait, what? This section, no. And you pass it a container of things. I think I might vibe code this. Okay, I'm gonna try to vibe code this right now. So, I'm just gonna ask Claude in kernel lib./test.cpp. I want a helper class for easily creating the test data to pass into bitmap allocator. I envision a memory map helper class that takes a std vector. And by the way, we can use std vector now because we are doing normal user space programming. So we have access to the full standard library of a std vector of this work. Shit, dang. And stores it internally, and then has a member function that returns a span to that internal vector. I mean, this is honestly like very trivial to code, even to the point where maybe I should just do it. So I'm just gonna make a struct memory map helper. We're gonna have the vector memory map helper explicit std vector lemine entry vec. Oops. Okay. And we're going to vec going to move the vector in, and then just going to be a std span. It's actually going to be a memory map span called span, and return vec.data and then vec.size. That's pretty much it, I think. So now we just, for example, we're just gonna do helper.span. Or shit. But wait a sec. No, it's not quite right because we need this, needs to be the pointers thing, right? So we're going to so it's going to be, we're going to store a span, and then basically the same thing here. So for each thing in, whoa. But wait, no, it's gonna be, wait, sorry, it's gonna be, wait, what am I doing? It's also gonna be a std vector. Pointers, call it mdata. So I'm not quite ready for that. So it's going to take the data and we're going to move it into data. And then for all of the ones in the data, we're going to take the pointers and write. And then our span is going to return the span of the pointers. Just double check this. We pass in a vector, we store the vector, we compute the equivalent pointers array, and then we expose that as a span. And I think this will work. So now this is what it looks like. And we can get rid of the fancy stuff to make this even more concise. So now this is what it looks like. And we can run our unit test, and I wonder if this compiles. It does compile. And it's seg faults. Oh, because obviously right here it's push back. Right, we're pushing back the pointer. That's why. There we go. And now our test case fails because we have the 2 here. And then now we'll fix that bug. And our test case and our test suite passes. So that's sort of what I'm thinking. That's sort of the idea here. And so now we have these, now it's like very easy to write some unit tests. And then now we can have another, no AI needed. Yeah, just coding it from scratch. And then now we can do a test that's like 1 page usable memory. And then now we can do something like this where we do, and the base is 0. And what? Dang, okay. I need to get this type back. So now let's do the length of one page. And so now we're given exactly one page of usable memory from the system, and we can allocate and we can check that the p-adder has a value. We can actually require, I guess, and then we can check that p-adder is equal to hex 1 is actually 0, because that was the base here. Maybe we'll make this let's just make it 2000 just to make that a bit clearer. Hex 2000. Oh wait, I need this thing. And then now we can do this one more time, p-adder 2, and we can check that this thing. Right, so that's sort of my idea here. So now we have a second unit test. We pass it a memory map with exactly one page of usable memory, and we just check. We check that we get it. We check that we try to allocate again, and there's nothing there. Let's just try to run this. Oops, FJ. Okay, man, linking takes a bit of. So that is passing now. Check that out. So, and again, if I go and inject a bug into the code, we should now get 2 failing. Check that out. So now, our first one fails. Because we expect that we don't have anything returned, but we actually do. We got a 2 back. And then over here, it fails because we expected hex 2000, but we got 2. So, and look at how clean these unit tests are. It's super easy just to pass in this array and I could very, very easily craft, what am I doing? I could very easily craft an arbitrary memory map. For example, these ones that I was just making are pretty silly, but I could very easily start to craft a more realistic looking memory map, like what we see here in my unit test, and test the allocator against various kinds of memory maps with holes, without holes, like all this stuff. So yeah. What's up, guys? Okay, so Juliana, I'm going to link you to my resources page, which is not necessarily the best resources, but it's some resources that I found. Yeah, and Hello Code, did you try this before? I mean, no, not really. It's my first time doing unit tests for an OS, so yeah. And then Nicolos, yeah, exactly what Ismail said. This is technically kind of my second one, but for the first one, I was just working on this coursework OS, which was pretty different. So now I'm kind of doing my own thing. So anyway, check that out. So that's pretty cool. Got some solid unit tests. Going. So that's going to be where I leave it off today, everyone. But I want to thank you for joining the stream. And yeah, I'll catch you next time. Saran, no, not really, just a hobbyist. Yep. Looking clean. Thanks, man. All right. Have a great week. I'll catch you in the next one. and I'll see you later. Peace.